Good afternoon, friends. It's my pleasure and privilege to welcome you all for this distinguished lecture series on energy efficiency. We are privileged to have Dr. Ajay Mathur, Director General of TERI, to deliver the lecture here today. Of course, Dr. Ajay Mathur does not need any introduction. Anybody, any of us who are attending this lecture, who has some connection to energy efficiency knows Dr. Ajay Mathur pretty well. Any of the, suppose you are thinking of a committee on energy efficiency, Dr. Ajay Mathur's name is the first one to come up on our list. If you are looking for some clarification, opinions on energy efficiency, we always think of Dr. Ajay Mathur. Anything on regulation, technologies, Dr. Ajay Mathur is the person to go to in India. So you are extremely honored and privileged to have one of the foremost experts on energy efficiency talking to us today as part of the distinguished lecture series. Dr. Ajay Mathur, for the purposes of record, is the Director General of TERI. He is also the member of Prime Minister's Council on Climate Change. Of course, all of us are aware of Dr. Mathur as the Director General of Bureau of Energy Efficiency between the years 2006 to 2016, where extraordinary activities were taken up under his leadership, including the star labeling, energy conservation building code, and the successful launch and of the implementation of the PAT scheme. Dr. Mathur earlier has worked with the World Bank, Green Climate Fund, and Sustain Energy in various capacities before he joined the Bureau of Energy Efficiency. Dr. Mathur also had the distinction of being India's climate change negotiator during the Conference of Parties in Paris in the year 2015. He is also the co-chair of Energy Transition Commission, a high-level commission comprising of global, industrial, financial, and think tank leadership. He's also a member of Global Commission for Urgent Action on Energy Efficiency, led by International Energy Agency, Paris. Apart from all this, Dr. Mathur has the unique distinction of being, one, a foremost expert on energy efficiency and a foremost contributor to energy efficiency to the country. And we have had the privilege of interacting with Dr. Mathur on various occasions. One thing which he had done extensively when he was heading the Bureau of Energy Efficiency was that he extensively engaged with all the stakeholders, more so with the industry. With the result, many of the programs which came out of the Bureau of Energy Efficiency were acceptable to all the stakeholders as well as extremely successful. Dr. Mathur is aspirational as well as at the same time realistic. And that's also contributed to the success of the various programs which are taken up under his leadership. Ladies and gentlemen, it's our pleasure and privilege to have Dr. Ajay Mathur speak to us as part of this distinguished lecture series on energy efficiency. For all the delegates listening to this lecture, we would have about half an hour of Dr. Mathur speaking to us. And then subsequently, whatever questions you have, please enter them in the chat box. My colleague Kiran would compile it and then request Dr. Mathur for his clarifications. Without much further ado, may I request Dr. Ajay Mathur to take the seat, please. Dr. Mathur.
Thank you. Thank you very much, Venkat, and a very, very warm thanks to you for inviting me to this distinguished lecture series. I also want to welcome and say hello to all the participants. It's such a pleasure to be with all of you again. When Venkat had asked me first to deliver this lecture, I was a little taken aback because, I was thinking, what is there to say? But as I thought over this, I thought there are 3 or 4 things that I would like to share with you. And these 4 things are, number 1, the continuing importance of energy efficiency in our energy economics. That's number 1. The second is the fact that there is a large potential for energy efficiency even now in all sectors that you can think of. The third is that as we move ahead, there will be new opportunities, let me say, or new areas that will open up primarily because of our climate change implications and drivers. And the last point that I want to focus on was the fact that as we move ahead, this area will now increasingly, I would say, not only from today, but from yesterday, start seeing the need for innovation that is relevant to us here in India. So these are the 4 points that I would like to focus on. Let me start with the first. We have had, I believe, and I obviously am very, very biased in this, I believe that we have had a reasonably successful energy efficiency pathway in the last 8 or 10 years. There are many, many reasons for this. I should not in any way reduce the importance of the shift that is happening in the economy of a move towards the services sector from the manufacturing sector, with the amount of energy used per rupee added, rupee of value added, or rupee of GDP in the services sector being much less than that in the manufacturing sector. And therefore, every move means that there's that much less energy used for each rupee of GDP that is produced. I think we need to remember this. The second is that in spite of that, approximately half of the savings that one observes, for example, by looking at the energy intensity data, that is the energy consumed in the country divided by the GDP, approximately half of it, or more than half of it, is because of energy efficiency actions that companies or buildings or users like you and me or people in the transport sector have taken. It is a matter of record that the average air conditioner that is sold in India today is 50%, 50% more efficient. That it means it uses half as much energy as those that were available in 2007 when the first data was gathered. It is similar numbers, not 50%, but actually in the case of refrigerators, it is even more. It is true even as far as cars are concerned. Cars today are about 33% more efficient. Not just cars, two-wheelers, trucks. Across the board, vehicles are approximately 1/3 more efficient than they were in 2007. Obviously, the total value of products that are used in the Indian economy has increased. Our GDP has increased. So it is not as if this has led to a reduction on the energy side. We still see an increase in energy consumption, but that increase in energy consumption, even before the pandemic, had more or less started becoming stagnant. In fact, it had become a matter of concern. It had become a matter of concern because there was this feeling that at this stage of India's development, we should still be seeing an increase in the energy use. But we are seeing it in very strange ways. If you look at the energy consumption in people's homes, what do we see? We see that people who add air conditioners now add more efficient air conditioners than the air conditioners added last year. When we talk about the total amount of energy that goes, for example, into the building sector, the buildings are more efficient than those made earlier. So when the natural rate of increase of buildings and of air conditioners becomes equal to the rate of decrease in their energy use, then we see this plateauing. But, for example, in the case of air conditioners, what we are seeing is a different problem. Now, the energy use is the same. In fact, the energy used in Delhi this year for air conditioning is somewhat less, total amount of energy is somewhat less than in the equivalent period last year, say May through August last year and this year. However, year on year, what we are seeing is that the total demand is higher. We are seeing more air conditioners, so the demand goes up. Demand goes up, but energy does not go up. This is a big change that the electricity system is now seeing. And I'd like to leave it with you because this becomes one of the problems that we need to address as we go along. Now, having said this, is this energy efficiency increase occurring everywhere? I would say it isn't. In the building sector, we are seeing energy efficiency in buildings that are made by people who are going to live in them or work in them. We still do not see very large increases in buildings which are made by developers and then sold to owners and then rented out to tenants. We are also not seeing very much increase in energy efficiency in the small scale sector. So I would think that there are still parts of the Indian economy where we need to focus on energy efficiency. And on the other side, even in places where energy efficiency has happened, I gave the example of air conditioners, the problem has changed. It's no longer an energy problem, but it is certainly a peak demand. So the first issue that I would like to leave you with is that there is still a very large number of people in this country who have now got access to modern fuels, either electricity or LPG. And their use currently is very small, it will increase. However, because these people, they may not buy the top of the line energy efficient equipment, but they don't buy the old energy inefficient equipment. Either what you are seeing is that the, for example, when somebody gets electricity and they want to put up lights, they don't put up incandescent bulbs. We are seeing that new houses are getting LED bulbs. This is a change because earlier on, we were seeing that new users of electricity were using inefficient products. Similarly, in the case of LPG, because of the requirements that the Ministry of Petroleum has put, whenever somebody gets a new LPG connection, the stove that they use has a minimum efficiency of 68%. Again, this is very different from the earlier days when the new users of LPG were using less efficient stoves than the ones who were using it or were richer in their incomes. So this is good. But what I think it suggests to us is that there is a lot of work as we go ahead. Nowhere is this clearer than in the case of industry. Some years ago, I think 2 or 3 years ago, several of us here, and Venkat was certainly part of it, and I think Kiran was part of it. The TIFAC, the Technology Information Forecasting and Assessment Council of the Department of Science and Technology, had created a group which focused on energy efficiency. What is the kind of energy efficient technologies that are needed? And in every sector, a number of technologies were identified. As I go through them, I see them falling into 3 large categories. It is too much to expect that I will bore you with a listing of the many, many tables that were created. But what is true is that they fall into 3 categories. And I think this is a good classification of where is it that we are seeing both needs and trends in energy efficiency. The first was newer materials. So for example, we looked at windows, double glazed and so on. So which met these better performance standards. We were seeing that new materials, for example, composites, which are coming in, which are stronger, have lower heat flow or electricity flow across them, and are still able to deliver the work on which they are produced. We saw composites being used to lightweight cars and so on. This was the first. The second was far better utilization of heat. Now, one of the things that has happened in the past 8, 10, 15, 20 years is a secular increase in the electrical energy efficiency in all the equipment and in all the installations that are there. But what we are seeing now is the need for, in a sense, heat efficiency as well as of the availability of equipment for heat efficiency. So across a lot of interventions, we are looking at waste heat recovery devices of various sorts. There are the standard waste heat recovery devices where waste heat in industry is captured and then converted into either steam or electricity. And even if there's a small amount, it adds to the overall efficiency. So the only point I'd like to leave you with here is that operating costs have suddenly become, not suddenly, have become more important, are becoming increasingly more important, and the COVID-19 economic lockdown has brought a far greater emphasis on operating costs than there even was before the lockdown. Now think of it. The economic recovery packages that have been made available provide credit for SMEs, for example. Therefore, first costs is something that you can take care of. A SME will buy energy efficient motors, for example. I know I'm giving too simplistic an answer. But what is now important for them is to be competitive in the Indian market and in the global market, that their operational costs are managed as well. And managing operational costs means that they are able to also be energy efficient. Because for many of these SMEs, the single largest conversion cost is either labor or energy, one of these two. So with electricity efficiency having been handled, the one which is being looked at these days is heat efficiency. And therefore, whether we look at the pulp and paper industry or we look even at homes, we, in the city of Delhi, you need heating maybe for 2 months or 3 months in a year at the most. Most of us, for those 2 or 3 months, thought it didn't matter very much as far as electricity bills are concerned. We used radiators, which used resistance heating to provide heat. What you are now seeing, and this year has been very, very surprising, we have seen air conditioners with built-in heating just selling off the shelf. We can't get it. I wanted to buy one, and I was told, there's no availability. Why? Because with an air conditioner, you're using a heat pump. And the efficiency of heating essentially falls to the electricity requirement falls to a third of what it would have been. Consequently, in the strangest of places, these kinds of interventions in heat recovery are beginning to occur. Therefore, in the years to come, and I will take this up at the end, in the years to come, one of the things that we are seeing is a need for a constant reduction in energy efficiency, which also means a decline in the energy prices that we pay. This is true no matter where your energy is coming from, whether the energy is fossil fuel based energy or whether the energy is coming from renewables. In fact, and now I'd like to move to my third point on climate change. In fact, what I would argue is that as we look to the future, more and more of the demands for energy efficiency will be driven by climate change. Now, what is occurring is that we are seeing a reduction in the prices of renewable electricity. Solar electricity today is the cheapest electricity available in India anywhere, but only when the sun is shining. At night, it's coal-based electricity which is cheaper, but probably for 2 or 3 more years. Why do I say 2 or 3 more years? Because the most recent tenders that the Solar Energy Corporation of India has brought out has come up with prices for round-the-clock renewable electricity, which is renewables plus a storage, batteries, which is price competitive with coal-based electricity. Actually, it's a little bit cheaper. In other words, in 2 or 3 years, we might get round-the-clock electricity from renewables, which is cheaper than that from coal. Yes, it will be cheaper, but it doesn't mean that it is zero cost. And once we have gotten used to this issue of productivity, of competing on the basis of lowering our costs, the venture to reduce costs will continue irrespective of the shift to renewables. Because when we get renewables, everybody will get the same benefit. Yes, there will be a price drop, but it will be a price drop for everyone. So if we want to use renewable energy, the challenge then for competitive reasons will be, how do I reduce the amount of renewable electricity? So at the same time, I am having a double benefit. I'm getting a benefit myself. I'm also reducing the amount of carbon dioxide that is going into the atmosphere. So I look at energy efficiency as the first step in the move towards decarbonization. Energy efficiency, followed by decarbonization of electricity, which is renewables, followed by the electrification of industry and transport using renewables. And the fourth is for high temperature and long distance transport using probably hydrogen, again, generated from water using renewable electricity. To me, these are the 4 steps that move us towards a zero carbon economy. As far as energy efficiency is concerned, it is important that the equipment that is used is energy efficient. So, for example, if we are looking to a future of renewable electricity or electricity in transport, batteries are very important. Batteries will need to be energy efficient, they will need to be cost effective. And therefore, energy efficient batteries is a here and now problem. Once you get the round the clock renewable electricity at competitive prices, the next challenge will be, how do I make it cheaper? And cheaper batteries, energy efficient batteries, will be the game that people will then invest in. The second area which I expect to grow is cooling and cold storages. Air conditioning I talked about the challenge of high demands versus relatively constant energy use. This is good, but what it tells us is that in order to get this air conditioning, even that peak load will need to be managed. Because if the peak load is going to be met by renewables, which are needed only for a few thousand hours in a year, then you have a problem. Because we'll have to put a lot of renewable PV load and use it for a very short time, which means that the electricity will be much more expensive. That would completely go against the longer term logic of reducing costs. I also mentioned cold storages. In this country, 2/3 of the cold storages that occur today are around towns. They're not in rural areas. Why? You need them in rural areas, so you don't need them around towns. The reason is the poor electricity supply. Cold storages need reliable electricity, and if they don't get reliable electricity from the grid, they generate it from diesel generators, which is very expensive. And that is why there's a limitation in the number of cold storages in rural areas. With reliable electricity occurring, but more importantly, with renewable electricity occurring, cold storages will grow. Now, cold storages is something, if they're getting renewable electricity, then you've got the renewables on one side, but on the other side, if you're getting electricity from renewables, you need to make sure that the heat loss from these cold storages is as low as possible. So energy efficient cold storages, again, become extremely important in the years to come. So whether it is a matter of design, whether it is a matter of operation, in both those areas, we will have to focus on how we build and design cold storage. The third area, which I think is going to become very important, and I alluded to it when I said the fourth step in decarbonization is that industry and long distance transport uses hydrogen, which is made from water using renewable electricity. Well, if it is made from water, it needs electrolyzers. Today's electrolyzers are 85 to 92% efficiency. They will have to be much more efficient for the hydrogen that is made from electrolyzers to be cost effective as compared to the hydrogen that we get today from natural gas reformation. Electrolyzer technology, and particularly energy efficiency in electrolyzer technology, takes into account a host of issues. It takes into account chemical engineering issues, but also materials issues, electricity conduction issues. In other words, this is at the heart of energy efficiency engineering and technology. Another area which I think is extremely important is steel made from zero carbon. When we make steel today in blast furnaces, we use coke as the reducing agent, and CO2 is therefore a natural byproduct. But if we want to make zero carbon hydrogen, what do we use? The only answer that seems to emerge is that we use hydrogen. We use hydrogen as a reduction agent to convert the iron ore into steel. And of course, the hydrogen that we get is from the electrolysis of water using renewable electricity. Is it possible? Is it cost effective? Possible, yes. There's one plant which is being built in Sweden by a company called Hybrid, HYBRIT, which is using this technology and showcasing that it can actually work. Cost effective, it is not. But then, if the decarbonization becomes very, very important, it becomes a policy issue, then this becomes the way to the future towards producing hydrogen, which does not generate, towards producing steel, which did not generate any CO2. This clearly is a futuristic technology, but I thought I would put it on the table because the thermodynamics of it, the efficiency, the cascades through it have not yet been studied. And I think this is at the stage where that preliminary material energy balances need to be applied. The last climate-related efficiency issue that I wanted to focus on was aviation fuels. The aviation fuels we use today are all fossil fuels. But the agreement that the International Civil Aviation Organization has already entered in, which the Indian airlines have already entered in, called CORSIA, looks at a stabilization of the CO2 produced from use. And even if the number of miles, the number of aviation miles goes up, the emissions of CO2 have to stay constant and then decline. And we are not looking at very far. We are looking at, I think, from 24, we will be in a pilot phase. From 28, we have to make it constant, 2028, which is not that far away. How do we do this? There are talks of electric aeroplanes. I would, however, put my money on biofuels. Biofuels can be used for many things, but in all of those applications, there are options that are there. But in the aviation sector, there really are no options, and I expect that we will see that the vast amount of biofuels that we have will go towards aviation. However, this would mean that the engines, the aviation engines, need to be reconfigured. They need to be reconfigured to work with the biofuel, with its properties, with its with the temperature at which it will, its volatility is different from that of aviation fuels, its viscosity is different, and therefore the engines would need to be redesigned to work with biofuels. Recently, SpiceJet flew a plane from Dehradun to Delhi with one engine working on biofuels. So technically it can. I mean, this is very much like the early cars in which If petrol was not available, you could put a range of other liquid fuels, benzene and so on, and it would run on it, and the engines would run. It's very much in the same thing that the engine runs. But does it run optimally? Does it run at the kinds of efficiencies that we are used to? No, it doesn't. And consequently, configuring those engines to be used with biofuels becomes an important. So this was the third point that I wanted to make, that there will be a number of energy efficiency issues that will arise as we move towards a low carbon economy. Let me finally speak about innovation. As we look to the future, we look at a huge number of applications where we will see new materials, new thermodynamic cycles, and in fact, new raw material combinations that we will need. We were talking, for example, of steel and using hydrogen. Now, the kind of iron ore that we find in India is very different from the kind of iron ore that we find in Sweden. And therefore, the technology, even if Highbright develops a technology that is great, will need to be at least tweaked, but I would say re-engineered for use in India. Similarly, if we are looking at hydrogen, given the shortage of water, I expect that there would be a huge premium on gathering the water back, and so that it is again available for splitting into hydrogen. Which means that the kinds of electrolyzer technologies that we will have will probably be those which build in this recycling as well, because the water that comes in would need to be distilled for it to come back here. And therefore, we are looking at technologies which are going to be somewhat different than the technologies that are developed globally. We know that already. We know, for example, that the air conditioners that are developed in India today are no longer the same as are used the world over. And this is because we have taken out all the efficiencies that we could using global practices. Now it matters how you tune it so that the interior and exterior temperatures are matched. The ICR, the Indian Seasonal Energy Efficiency Ratio, is now what governs efficiency of air conditioners. And this means that it has to be configured so that it catches the optimal efficiency at a range of temperatures that occurs in India. If you talk of huge efficiency of air conditioners in Korea or China, it is immaterial. The temperatures there are much lower. Their efficiencies will be higher. To get the same efficiency here is a lot more difficult. Consequently, whether it is because of the new applications, whether it is because of the new materials, whether it is because of the carbon requirements, or because it is because the additional efficiencies are obtained as a result of tweaking the technology to meet local raw material or temperature conditions, there is a need for innovation. And one of the things we've learned about innovation is innovation occurs when you see a demand for the more efficient products. Thankfully, we are seeing a demand for more efficient products. But it is a scattered, it is a fragmented demand. The EESL experience with LED bulbs taught us that aggregation is an important issue, at least in lowering the prices. I would argue that it is also important for enhancing efficiency, because beyond a certain point, the lowering of prices will occur only because of the increased efficiencies. In fact, we have seen it now. The LED bulbs that you get now have got lumens per watt, which are at least 20% more than they were in 2015. What I hope that we have been able to focus on is the fact that energy efficiency is here and here to stay, but it is a demand that will keep on happening and keep on happening forever. I also hope that we have looked at the kinds of efficiency, the drivers of efficiency, the ways in which efficiency, where is efficiency becoming visible. And I hope that we focus on stimulating innovation and the challenges of aggregating the demand have been highlighted. With that, Venkat, let me again thank you for this opportunity and thank the audience. And if there are any questions, I will be very, very happy to address them. Thank you so much.
Dr. Mathur, thank you very much for your address. You covered all the key points that you laid out in the beginning of your speech, sir. There are quite a lot of questions. One request to all the participants is to please type in the questions in the Q&A window, and to facilitate the discussions, I'll just summarize the questions and maybe pose it to you for addressing them, Dr. Mathur. One set of questions were around the policies. So the question was more around what are the key policy changes you see coming up in near future that could accelerate the energy efficiency agenda in the country. So what are the policy changes that you would like to see in near future to accelerate it?
Thank you. I foresee two, possibly three major policy interventions in the near future. The first is the clubbing of energy efficiency savings and carbon savings. What that would do is create a demand for energy efficiency, which leads to lower CO2 emissions. And what that would also enable us to do is to be able to provide the kinds of carbon savings that occur. We could, for example, meet the demands of the aviation markets by providing offsets that they could purchase for them. So that is number one. The second change that is going to occur, and this is particularly true as more and more renewables come into the grid, is a market for both for capacity, the peak demand, as well as for energy, which is the total amount of energy that you need. Now, energy is something that we are used to. Energy efficiency is about lowering the demand for this energy. But I think what we will start seeing is that even in non-industry, industry has got a peak demand on the basis of the demand load. And in many industries, one way of reducing your energy bill is by enabling a lowering of demand. But given what is happening, I see a more dynamic pricing based on the demand. We have already seen in many states that the peak demand in your tariff is now much higher than it was a few years ago. This is a tendency that is going to happen, and therefore, in terms of operations, lower energy costs will become more important. The third, on which I am not as sure as I am of the first two, is a linkage of the property taxes of energy efficient buildings with their buildings with their energy efficiency. You are based in Hyderabad. The municipality of Hyderabad has started talking about linking this. The municipality in Noida has started talking about linking this. I'm not very sure whether they will go anywhere, but that's the 2.5 policies that I thought I would mention.
Thank you. Sir, the next set of questions are around industrial energy efficiency, and like you would always refer to as a boiler room discussion to be taken to a boardroom level. Now, there is some amount of progress which has happened. There are some boardrooms which are sensitive, which are responsive to energy efficiency. But what, in your opinion, can the industrial sector do more in taking it to a boardroom level, in taking the discussions to a very high level of implementation and awareness, sir?
So the one thing that has started happening is that because of the reporting requirements, we now get boardrooms involved. But one of the things that has also started happening, and we need to make sure that more of this happens, is that financing institutions have now started asking about energy efficiency. What that does is that, for example, a loan is something that boardrooms do look at. And if they are forced to look at energy efficiency and therefore on repayments, which are premised on particular energy efficiency calculations, that zeroes in on more energy efficient products than is ever possible. I would also argue that the discussion around competitiveness for many years had focused on increasing the top line. I would suggest that we have started seeing some in some boardrooms a discussion which focuses on reducing bottom lines. This is what energy efficiency is about, that your costs are lower. My feeling is we need to start focusing on that as a competitiveness measure more than anything
else. Thank you, sir. I think the point, just extending on your point on finance, sir, one of the questions that has always been is how do we make more finance available for energy efficiency projects, be it either in terms of interest subversion schemes, or what kind of financial support do you think would make energy efficiency attractive? Is such a financial support required? Or if it is required, what kind of schemes do you think would make it more attractive?
You know, I am firmly of the opinion, have always been of the opinion, that energy efficiency does not need any subventions. Because energy efficiency produces gains from day one, there is no argument for lowering the interest rate or providing subsidies. However, this is not an argument in the absolute. So what are the cases where subventions or subsidies may make sense? I would argue the first is new technologies. The risks associated with new technologies, including the fact that I'm junking my old technology, which is working, and I'm making profits on it, with a new unproven technology, it's a huge risk. And that, I think, there has to be a reward associated with it, whether it is through a grant, the MSME program of providing 10% support for new technologies is one of the examples of that, or for providing lower cost capital. So one is new technologies. The second that could happen is for small scale industry. Because for small scale industry, one of the problems that occurs is that their transaction costs tend to become very high as a proportion of the cost of the main commercial deal. And if that is the case, then they find that the overall cost, commercial cost plus transaction cost, that the overall cost is not making sense. That may be another case where some kind of intervention, some kind of subsidy could be provided. But what is the problem? I believe that the main problem is the lack of an ability in the financial sector to be able to lend for projects that are cost effective. So if you have an energy efficiency project that makes sense, can I lend for it on the basis of that project itself instead of asking for a separate collateral? I hope that we will move ahead in this direction. One of the hats that I wear is as a director on the board of Tata Clean Tech Capital, where one of my aims is to make capital available to companies which are going in for energy efficiency in a manner that captures the savings. And therefore, it is the savings that I think need to be risk assured, and therefore there are all kinds of permutations and combinations that we are looking at. That there is a minimum savings that occurs, and above that there is a volatility. And what we're looking at is a confidence that the volatility is what will also be achieved in addition to the base savings that occur. But I think it is steps in that direction which would help us provide a lot more funding for energy efficiency than we have had in the past.
Thank you, sir. Another set of questions, quite a lot of questions actually, were around ESCOs, sir. ESCOs has been something where there have been a lot of discussions happening in the country, but compared to the market size that it offers, still the number of ESCOs were active and the number of energy efficiency projects which are taken up in this route are still very, very small. So what, in your opinion, could accelerate it, sir? Is it vendor ESCOs? Is it availability of finance for ESCOs? Or is it an insurance for ESCOs? What do you think will accelerate energy service companies in the country?
This is a question that I have often grappled with. Initially, we thought it is the availability of good projects. And therefore, we got a set of good projects in which started saying we will do it through ESCOs. Then we thought it is the availability of high quality ESCOs. So we got ESCOs rated and brought them. Then we thought it was standard agreements. We got those done. Even then, ESCOs have not taken. What has taken off is when equipment is sold with appropriate guarantees, the so-called vendor-based ESCO. So now the problem is that the manufacturer is not in the business of leasing equipment. He's in the business of making equipment, selling equipment, getting the money and making more. And consequently, what you need is a financing agency that has both the right risk, cost, and reward system to be able to combine with this vendor-based ESCO. I would argue that EESL performs in that role. Is there a place for more ESCOs? Yes, of course there is. If I look at the MSME sector, the MSME owner, he's the same guy who is the chief executive officer, he's also the chief marketing officer, he's also the chief finance officer, everything. He says, I am not going to spend time figuring out if this will work or it won't work. Can somebody put it in and guarantee that it will work? Therefore, if a vendor-based ESCO goes to him and says, listen, this will work, you pay on a certain basis, but in the meantime, we guarantee it fully. Then the owner, the SME owner, is much more likely to take up that technology. So I am still unsure about whether a market exists for energy efficient projects. But what I think the market needs, what the market is doing and can be expanded is for energy efficient.
Thank you, sir. There are again a whole lot of questions on what would be the role of the Internet of Things, automation, Industry 4.0 on the entire manufacturing segment, and more particularly on the energy efficiency space, sir. How do we think these could change the way energy efficiency is looked at in future?
These go back to the point that even today, companies that are efficient put in monitors, but somebody goes and reads them, or in companies that are good, they will install a SCADA-based system which collects information and gives it in a certain form. What we have not yet become used to is that information is used for control in a direct basis. There's typically manual intervention. And therefore, learning from previous experiences and using that learning, so-called machine learning, on an automatic basis so that it keeps on improving the decision-making power of the equipment, so-called artificial intelligence, that is where I believe that we will be able to get energy efficiency to be able to extract the last bits of efficiency. Because what it will do is, for example, whether it is temperature or whether it is the amount of load that a machine has, those can be managed on a regular basis. In fact, with learning, the machine can learn if this is the way in which the trend is happening, then I expect that the next thing will happen is this, I'm ready to do it. So I am 100% sure that Internet 4.0, industry will adopt this for productivity reasons, for reasons of enhancing their competitiveness, and in the increases in energy efficiency that are associated with real-time measurements and real-time interventions will come into play as a result of these interventions.
Thank you, sir. Sir, the last point in your speech you mentioned was on innovation, and you mentioned how there is a need for innovation that is very relevant to us to be developed. But usually innovation is expensive. It requires a huge amount of investments, both for the development as well as its deployment and then the scale up. How do we handle this this whole the finance part of innovation in the country, sir?
Okay, innovation is many things, and it means different things to different people. If you go into the factory of a motor manufacturer, he will say, if I have put a Danfoss driver, I have done a huge amount of innovation. He says that. Danfoss will also say, I have put in a huge amount of innovation in developing the driver. Which innovation is more important? Both, I think. In other words, there are different kinds of innovations which occur at different places. And I think what is most important for us right now is that the energy efficient driver is available. And there are people who know how to use it, to put it on the motor so that it becomes energy efficient. As far as money is concerned, again, this is different things to different people. So, in the air conditioning world, people brought in VRFs, and it is sold as the latest thing in innovation, and I think rightly so. On the other hand, there are people who are developing air conditioning which is based on different kinds of cycles, natural cycles and so on. And they call it innovation, rightly so. The point that I want to make is, again, that you will see different kinds of innovations. Look at the car industry. The Ciaz is a hybrid. The Toyota Prius is a hybrid. The Toyota Prius costs much, much more than a Ciaz. In terms of the mileage, one can even argue that the Ciaz gets more mileage. Yes, it's a lighter car. If you correct it for weight, it's probably similar. In other words, there are two different approaches, very different approaches to innovation. I will leave you with the fact that innovation depends on the market that you face. And as far as funding is concerned, the people who do different kinds of activities get different kinds of funding. I don't think there's anybody who's ever had a problem that they couldn't get the funding because they were doing an innovation for a market that they knew. Yes, people have not got funding when they wanted to break into new markets. So if there is a funding problem, the funding problem is for startups. But that's a more general problem than being an innovation financing problem. It's a startup financing problem. I would argue that understanding the market is far more important for innovation than is the availability of financing.
Thank you, sir. The next question is, I mean, there is generally a saying that India's GDP is far less energy intensive. Do you think it is true? And if so, how do we compare with other countries, sir? And which country do you think can be something that we can look upon to? Which country can we take as an example when it comes to energy efficiency at a national level?
So India does have a low and declining energy intensity. That there is a problem in comparison, because if you want to compare, you have to convert it into a common source. It is, for example, dollars, kilograms of oil equivalent per dollar of GDP. But GDP in India is in rupees, not in dollars. The GDP in Japan is in yen, not in dollars. So once you convert it, there is already a problem that starts happening. I think, therefore, it is not so much the absolute values as the trends which matter. Which are the countries that are worth emulating? Clearly, either Japan or Germany. These countries, not only in innovation, not only in demand creation, not only in the availability of products and services, but also in use, have brought energy to a completely different level. It's become a social conversation. In Japan, people discuss whether the temperature in the air-conditioned room should be kept at 26 or 28 or whatever. That creates the kind of public pressure that is needed for the use of the efficient, efficient use of energy, and not just one of the many silos that I identified.
Thank you, sir. Now, my last question, sir. I know we are at 5 p.m. and my last question is, over the years, sir, we have a large pool of energy efficiency professionals in the country. But when we look at the list of things to be done, there is a requirement of a larger pool of young professionals to come into this domain. What are your words of advice for people, for smarter people who are looking at making a career in the energy efficiency domain, sir? What do you suggest they should look at, and what are the areas they can pursue in future?
So again, one of my learnings is that a good energy efficiency professional is first a good professional in the domain or sector of application. So you are a good buildings expert, or an air conditioning expert, or a furnace expert, or you are an expert in how steel is made. But with that, you're also an energy efficiency expert. What that allows people to do, so for example, I'll give you an example which many people in the audience could relate with, is thermal power plants. You have to understand how a thermal power plant works. Then you can start applying energy efficiency, because it's not just one unit, but it is across several units that you have to work together in order to achieve energy efficiency. Short point, we need to ensure that we mainstream energy efficiency into these sectors. I think the main step is to get good professionals from various sectors and build up their energy efficiency capabilities.
Thanks a lot, Dr. Mathur. Thank you very much for joining us at the session today. Thanks for your address and thanks for patiently answering all the questions that came up from the participants. Thank you very much for your time. Thanks a lot, sir.
Thank you. Thank you.
Thank you, Dr.
Very
Mathur.
much.
Thank you. Thank you, Dr. Mathur. Thank you.
Thank you, Venkat.